Software Engineering Radio, Episode 46, Refactoring Part 1.
In today's episode, I'm going to talk with Martin Lippert. So Martin, do you want to say some words about yourself?
Hello, Eberhard. Thank you for being on this show. So my name is Martin Lippert, and I'm working as a consultant and coach for IT Agile. It's a small consulting company in Germany, in Hamburg. And my main focus is working on agile methods on the one side. So I'm helping teams to become agile, to adopt agile methods, to stay agile, and to improve their development process. And on the other side, I'm working on agile technologies or technologies that are somehow related to agile methods. So I'm deeply involved somehow in this kind of Eclipse technology, and I'm interested in Spring and stuff like that, and how to combine all these technologies. So, and one of my favorite technologies, that's related to agile methods is, of course, refactoring, and that's why I'm here today.
Okay, so today we are going to talk about refactoring. So first of all, the question is, what does refactoring actually mean?
So refactoring means improving the internal structure, the internal design of a software system without changing the external behavior. So that basically means to improve the design, to restructure the software, without adding features, without removing features, without changing the real behavior. You can discuss a lot what the behavior means, if it means the performance, or if it includes just the UI or the API or whatever. I think it depends on the context of your software, but it basically means improving the internal structure to maintain and to cheaply modify the software in the future, to keep it healthy and to keep it soft.
Okay, so where does that term come from? Who coined it?
The term origins in a workshop paper that was published at a Uppsala conference in the early 90s, and I think mainly William Opdyke. He wrote a PhD thesis about refactoring object-oriented systems for Ralph Johnson at the University of Urbana, Illinois, I think, and that was in 1993, I think. And he, let's say, he researched all the basic ideas behind what is refactoring and how does refactoring works and how is refactoring different from just changing a piece of software. And the next breakthrough was done by Don Roberts and John Brandt, and they built a refactoring tool support. They built the real first browser refactoring tool for Smalltalk, and I think that was at that point in time was more some silent about this around this kind of refactoring ideas, and the real, let's say, worldwide breakthrough or real main interest gained in the term refactoring in the late 90s with a book by Martin Fowler about refactoring, and with the movement of these agile methods, where refactoring is a main part of.
So, why did Martin write that book? I mean, at that specific time, even though the idea was already quite old?
I think the idea became much more important in this area of agile methods, because in agile methods you typically you start with a very, very small implementation, a small system, and you basically working all the time improving an existing piece of software. And the idea of incremental design and creating the architecture of the system over time basically means that you need to improve the structure of your existing system all the time, every day. All the time you work on the software. And I think therefore it was really important to have some kind of guidance and kind of tool support, and then maybe a good book like the book by Martin Fowler to give you some hints and tips and tricks and provide some nuts and bolts of what to do and what don't to do, And the book is real. I think it's a real brilliant book, and everybody should read it. Even if you do not do agile or extreme programming or whatever, it's just some fundamental know-how how to work with object-oriented systems. And in the book, I think the big two parts are, on the one hand, he tells you a lot about what are the smelly points in the system, what he calls a cold smell. So what is an ugly design, or what are the typical pieces of code where you should change the internal design, the internal structure. And on the other hand, he gives you a lot of advice and a lot of patterns, what or how you can improve the internal structure, internal design. So he gives a lot of guidance how to, let's say, how to rename a method. How can you rename a method? It sounds like a very, very simple refactoring, but if you do not have tool support, you can think a lot of, if you have a huge system with thousands of dependencies on one particular method, you can think a lot of how to step by step implement this kind of refactoring without breaking the system for a long time. So the whole idea is based on doing small changes, testing small changes all the time to keep you happy and safe, that you do not introduce new bugs while you're refactoring the software.
One of the first things, obviously, for refactoring is to know when to apply them. So you were talking about code smells, and how do you actually find them? I mean, not everybody can sniff the software, so to say, right?
Yeah, that's right. That's right. I think sometimes you just need a good experience and good know-how from several systems you've built in the past. On the other hand, in the book there are many cold smells described, and there exists some tools which try to identify cold smells, try to sniff cold smells. Some tools like maybe find bugs. This is a very simple tool, but it's a very fine granular level. More sophisticated tools, they try to analyze structures, dependencies between classes, dependencies between packages, sizes of methods, for example. And they can tell you, for example, oh, you have a class that contains a method. It's quite long, and maybe you should think about extract method or split it into different methods. So there are some tools, I think.
So is it rather something that you can say there is it hard scientific things to say this is a code smell or not, or is it rather something that comes out of experience and more like soft know-how?
I think it's more a question of soft know-how than any experience. It's more like you have to implement a new feature for a piece of software, and you take a look at the structure, and you find out that the structure simply does not work for a new feature, or it's quite complicated, or you think or you find in the code many different pieces you need to change to implement a new feature. I think then you have a good feeling about what part of the structure is not good and does not fit into this new feature. And I think then, based on this experience and this just reading code, you can identify a lot of these code smells just yourself without any kind of tools.
Okay. So how does that fit into daily work? How do you do refactorings? I mean, some of the projects that I know say you do a period of refactoring after delivering a release, for example. So is that a valid approach, or how do you do that?
My point of view is that refactoring belongs to your daily programming work. So if you implement a software, it's just like creating a new class is refactoring all the time. So I'm refactoring my project or my piece of code all the time. I rename methods, I split methods, I extract code, I rename classes all the time to keep the design healthy all the time. Because if you think about it, I just put this piece into the software, and it doesn't matter if it's ugly or not, if it smells or not. It doesn't matter. After the next release, we have plenty of time to improve the structure. My experience is that you will never get the time to improve the structure, and even if you get that time, it's much more complicated to do the refactoring after you have implemented for several weeks or months features than if you do the refactoring all the time. So it's really, I think it's for me, it's, maybe you can say it's more important than programming.
Okay. So what you're saying is such a period of organized refactoring is not something that you should do. Then, I mean, the next question is how do you actually make people refactor? Because obviously, this is what you're saying is it's something that every programmer is supposed to do as an ongoing task.
Yes.
And much like test-driven development, for example, there are a lot of programmers that will most likely not do it. So how do you deal with that problem?
I think it's a different problem because I think somehow it belongs to every developer to do refactoring all the time, and it gets hard if you have a team where 5 people do refactoring all the time, and then it belongs to their daily work, just from a natural point of view. And some people don't, so it's quite hard to convince them that refactoring is good. So maybe you can do pair programming with them and try to give them maybe not to teach them refactoring, but to give them an impression how refactoring really works, and that refactoring is, if you do it on a daily basis, it's an easy task. It's not a complicated stuff. It's really, with the tool support you have today in the modern IDEs, it's really easy to refactor. It's easier than creating a new class maybe. So it's really easy, and everybody should do it. But if someone is convinced that refactoring is not necessary at all, and it's just stupid and useless work, so maybe it gets hard to convince those people just from these theoretical points of view.
Okay.
But I think it's just if you want to create a software that's healthy over time, refactoring is, you cannot do it without refactoring.
Yeah, that's certainly true. We have already, I already mentioned test-driven development. So what is the relationship between refactoring and test-driven development?
I think the relation between test-driven development and refactoring, think about it. I think test-driven development is a development approach. So you do test-driven development, and you create a test class, and then you implement the code. And because of refactoring mainly belongs to implementing the code on the one side, it's just you write a test case and you implement the code and think, I need to refactor some stuff, and then you refactor the stuff and you make the code the test green. So that's one aspect. Another aspect is that refactoring, if you do not have real safe tool support and you do manual refactoring stuff, and you really need a test suite and a test case to be sure that you do not change the behavior, you do not introduce bugs and stuff like that. So refactoring without tool support and without a good test suite is like doing some crazy stuff without a safety net. So you really need the test case as a safety net. That's the second level, and the third level I think is what some people say, that you need to refactor your test cases as well, not just the code, but you can also think of code smells in test cases. So many similar test methods or huge setups or whatever, where you need to refactor your test cases as well.
Yeah, because you need to have the same quality in the test cases as in the real code.
Yeah, exactly.
Okay. What do I do? So basically what you're saying is if I don't have any test cases, and I have bad quality of code, I'm basically screwed because I can't do any refactoring. So, and I will have this bad quality forever. So what do I do in that situation?
I think the real challenge then is to write test cases for that code and then refactor the code. But it's not always that easy as it sounds like. Because in most cases, if you do not have test cases, it's really, really hard and really complicated to introduce test cases for some classes that are written without any unit tests in mind, and they're not really testable. You cannot inject dependencies or whatever. So you really need to maybe somehow get a first step into that class to make it testable, and then write a piece of test code, and then maybe change another small piece of the class to make it even more testable, and then write some more tests. And if you have a good solid test case or test suite for that class, you can do the real refactoring work. But of course, these small changes at the beginning was also refactoring.
Okay, so I think there is a book about that, working efficiently with
legacy code. It's written by Michael Feathers, and it's titled Working Effectively with Legacy Code. It's a real nice book where he describes a lot of techniques, how to implement those tests, and what techniques you can apply to implement those tests, like smoke tests and stuff like that. It's a nice book.
Okay, talking about books, we already mentioned the Fowler book. So, and that I think gives a collection of refactoring patterns. So, why should I read it? I mean, what's the benefit of reading through that?
I think that the benefit is that you, first of all, get an idea about typical code smells.
Okay.
That's one factor. And another aspect is that you get a real great impression how to step-by-step refactor a piece of code for a specific situation. And he provides a lot of stuff like how you can step-by-step rename a method, or how you can split a hierarchy, or how you can change inheritance hierarchies, how you can change relationships between classes and stuff like that. And it's a real it's maybe not a book which you need to read from the first to the last page once, but it's really worth to read all these patterns and all these refactoring guidance that's provided in the book, to get a feeling how I can change the internal structure without changing the behavior, and how I can move forward in small steps.
Makes me wonder whether there are any other refactoring patterns or books that I should read with regards to refactoring.
There exist some books, some more books. So the Martin Fowler book is the refactoring book, of course. And there's a refactoring workbook written by William Wake. It's more some kind of practical guidance how to learn refactoring and how to do some practical examples and stuff like that. It's also a nice book. And if you take a look at those two books, they're both, and basically the book by Martin Fowler, they're both on this base level of refactoring. They're working on the class level, on the relationship level between single classes, and all these object-oriented concepts, like inheritance or relationships and stuff like that. They're not working on higher levels. I think there are two refactoring patterns that are focused on more high-level refactorings, like separating presentation from domain. But it's really it remains vague in the book, the guidance and the examples. So the next step, I think, is the book written by Joshua Kirievsky about refactoring to patterns, where he analyzed what are typical situations and typical code smells where you, for example, should introduce an observer pattern.
Okay.
How you can introduce or extract a visitor pattern from your code, or other patterns, a lot of patterns in that book, and how you can refactor to patterns, to the typical graph patterns, I think. And on the other side, the opposite refactorings as well. So how you can remove an unnecessary implement a pattern from your code where it's not really necessary, where it makes the code more complicated than it needs to be.
Yeah, I actually believe that refactoring can be done in both ways. So to say, forward and backwards.
Yeah. Okay. So you can extract a method and you can inline a method, and it's both worth. So it's not really an extract method. It's a better refactoring than inline method. Maybe if it seems so, but it's really worth to get an impression of both sides.
Okay. You have already mentioned some tools like the original Smalltalk refactoring browser.
Mm-hmm.
So which tools should I be aware of? and which should I use?
I think today the modern the current IDE implementations like Eclipse for Java or IDEA for Java or whatever, there are a lot of tools, and I do want to advertise some tools here, but all these modern IDEs they all implement refactoring support on the base level, so you can rename a class, can do all these renaming class methods, whatever, and you can do movements and most of them provide even advanced refactoring support on the level of single keystrokes. You can just rename a class with a single keystroke. You can extract a local variable with a single keystroke. As really, you need to have it somehow in your blood and in your fingers to have all these keystrokes available all the time to do the refactoring all the time. And this refactoring support is really it's great. I don't want to work without such a refactoring support in such IDEs, because it's really great support. Yeah, what is important on the one hand is that there exist two different kinds of refactoring supports or refactoring support in such tools. On the one hand, you have tool support that really is safe, where you can believe the IDE that it takes care of changing all the references to your named class and changing all these whatever, that you do not change the behavior of your existing system, and you can be safe that it really does not change the behavior, and it takes care of that. It ensures you for you that. And on the other side, there are some refactorings that are more advanced and more complicated and more general, maybe like change method signature. Or even extract method in some situations is quite difficult in Java to implement, where the IDE cannot give you the safety of that the behavior is not changed. So it's great to have all these IDE support, because it makes it easy to refactor, and it adapts all the references and stuff like that. But it does not give you the possibility to skip your safety net, to skip the test cases. You always need the test cases, even if you have great tool support by the IDE.
So, but there are other like specialized refactoring tools outside of typical IDEs, because so far you've only talked about what the IDEs support.
I think there exists some for example for Eclipse there exists some plugins which provide additional refactoring support, and I think for the Visual Studio world there exists some plugins and some additions that provide refactoring support for that. But I'm not aware of special other tools that gives you provides you some help or some support.
Okay, so basically I should use the IDE and that's it.
I think so.
One thing that I find quite odd is today people talk about a lot about Java and being statically typed, and the advantage of Java offering more support for IDEs, because you can reason about the type and therefore have better possibilities for code completion, for example, or even refactoring.
Yes.
Even though, I mean, the original refactoring browser that we've talked about was for Smalltalk, so for a dynamically typed language. So how does that fit together? Even though refactoring appears to be something that is really good, really well supported by statically typed languages only, it is a concept that was introduced by dynamically typed languages.
I think the main reason is that most of the research was done in the early 90s in these object-oriented world in the Smalltalk area. And it gives you a lot of possibilities of implementing stuff into the IDE and stuff like that. So it was the research stuff for that. The refactoring support that was built into the Smalltalk refactoring browser was really great for that point in time. But if you take a look at it, if you compare it to the statically typed languages, it's it's really complicated to do a renamed class or renamed method in Smalltalk, and finding out where is this method called and where it's not called, where it's another method meant. And sometimes they just say, okay, I just rename every method in the system that is called whatever to whatever new, without analyzing if it's really the same method or it's invocation of the same method or a completely different method, because it cannot know which method was meant, because it cannot analyze the static typing of that system. So it's a lot easier to implement this automatic refactoring support for statically typed languages, and it's much more complicated to do it for dynamic languages. I can't believe that there might appear some refactoring support tools for dynamically typed languages, but it's a lot more difficult to implement and to realize. Interestingly, people who were working on, for example, a Ruby on Rails project, they told me that they're really big fans of refactoring. They told me that they observed that they do not need to refactor so much in the dynamic language world, like they do typically, or they need in these statically typed languages. I do not know why, and they could not explain it to me why they do not need to refactor so much in the dynamic world, but it was just an observation or maybe just a feeling, and I found it quite interesting. I have no experience myself with these dynamically typed stuff, so I cannot really prove it or explain it where does this feeling comes from, but it was an interesting observation, I think.
Or maybe if you don't have such a good IDE support, you do it less regularly, but I mean, who knows? I read some reports that said that there is a risk of refactoring yourself to death, so to say, so that you just do refactoring all the time, and you do much more refactoring than you do actually implementation work. Is that a common problem, or I mean, isn't it naive to assume that you can just hack away and then refactoring will take care of all the ugly stuff that you're doing, and that will still be an efficient process of implementation?
I think you need a good balance between programming and refactoring. I think, and I know many people, and sometimes I belong to this group where I think, oh, I can improve this more, and I can improve it more and more and more, and it gets beautiful and more beautiful code, and I love this piece of code and makes it even more better and whatever. I think you need, it's just somehow you spend a lot of time doing this stuff without really improving the internal structure, without getting some kind of benefit out of it. I think you need a good balance between these two forces of implementing stuff or adding features and refactoring. And I think the main goal, or the main motivation for me, is to keep a software system soft and healthy. Not to keep it over healthy or over soft or completely flexible for everything. Just being pragmatic and say what are the current features I need to implement for this piece of software, and what is a good structure for that. And if I implement a feature and I think after implementing the feature, how does the design looks like? And I think, okay, it smells somehow, and I improve it, but I just improve it until it does not smell. So just do not improve it to the ideal best design ever known or whatever.
Okay, so if you take an economic perspective, it's basically an investment into the future. So you're saying, okay, I have this piece of code, it has a bad design, and I assume that by improving the design, I will have a higher productivity in the future. And how do you judge whether this refactoring will pay off as an investment? And will not be something that is just code beautifying?
Yeah, I think really judging or measuring it in money somehow, it's quite difficult, because it's who can really measure how maintainable a piece of software is, or how much does it cost in 5 years to add new features. I think it really pays off quickly if you have a healthy software system, a healthy design, and if you refactor all the time, because it doesn't matter if you implement the feature today or in 5 years into such a piece of software. It always costs the same. It does not cost, okay, if we implement it, or if you think about this feature now, it's cheap to integrate into the system, and if you think about it tomorrow, it costs a lot of money. Because we need to change a lot of code, and we need to refactor the basic architecture of the system or whatever. So I think it's more this kind of idea. If you are going to implement a piece of software that lives for a longer period of time, maybe for a month or for years, or maybe for a dozen of years, I think it's an inherent goal of keeping this piece of software healthy. And I think the only way to keep this piece of software healthy is to do refactoring from the first day on, all the time. So you cannot, from my point of view, you cannot live without it.
Okay.
On the other hand, I'm pretty sure that there exist projects where you just implement, let's say, one-way software or throwaway software.
Yeah, at least that's what you think you're doing.
Maybe, and I know of situations where this is really true, because I know of people, they're implementing software for brokers, and those brokers, they really needed software for tomorrow, and just for tomorrow, and just for this specific contract, or for this specific market situation, or whatever, and they needed really a highly specified piece of software just for this deal.
Okay.
So they program the software, and it doesn't matter if they do copy and paste or whatever. They just need it for one day, and they throw it away after the day. So, and then they need maybe another piece of software the next day.
Okay. So what you're saying is basically that it's a technique that I'm using on a more fine-grained level, and also it is something that you somehow need to judge when to do by your experience. So what I'm wondering is, should a manager or a project leader care about refactoring, or is there anything from the management level that you can do with regards to refactoring to enforce it, or is it just some fine-grained stuff that a good developer does?
I think the goal from the management point of view is to take care of a good design in your software, and because you would like to have a piece of software that is maintainable and changeable in the future. That is your management goal. You would like to have a piece of software that in 2 years you can add features with the same speed and with the same quality as you're doing now. So maybe it's a goal for the management, but I think it's often a goal for the from the management point of view. And maybe it doesn't matter how the team realizes this goal, or how the team ensures that adding this feature, or whatever features needs, or whatever changes and requirements they may occur in the future, can be implemented fast and quickly and on a high quality level into the software. Maybe it doesn't matter how the team ensures that that's be able in the future to do this, but I think that refactoring is the most important technique for the team to ensure this goal. So it's not really, I think refactoring as a technique itself maybe does not matter to the management so much. It's more the effects that you create with refactoring that matters to the management.
Is there some advice that you could give to a project manager, whether when he should bring in someone that looks at this, that improves the refactoring techniques in the team? So is there some kind of hint that hints a manager, okay, so obviously the team is not doing refactoring in a proper way, and for that reason we now have quality problems, and I need to find a way of improving the refactoring knowledge in my team?
I think of course getting people into the team that are experienced on refactoring, that they can teach other people, or they can show other people how to refactor and how to improve that design is always useful. maybe have a consultant or whatever for a limited period of time inside the project that is experienced with this kind of techniques. But I think for many teams that I know or where I was involved in, it's difficult to say, okay, here's a book. I read this book. It sounds good, and just do it from the management, because all the developers think, okay, he's a manager. He does not know what really happens here inside the code or inside the system. Let him tell everything, and we will throw it away. Just a book, put it into the whatever, and
on the
that's
board.
it. On the board, yeah.
Okay, so thanks a lot for talking about refactorings. We will have another episode that is going to be going to talk about big refactorings with Martin as well. So stay tuned for more information about refactoring in the next episodes.
Thanks for listening to Software Engineering Radio. If you want to get more information about Software Engineering Radio, or if you want to give us feedback, please go to our website at se-radio.net. You can also contact the team at team@se-radio.net, although we prefer entries in our comments system on the website so other people can see what you think. Software Engineering Radio wants to thank Henning Pauli for the intro and outro music, as well as Libsyn for providing the bandwidth. This episode of SE Radio, as well as all other episodes, is licensed under Creative Commons license. See the Software Engineering Radio website for details.